So today we're going to be talking about txtai, which is a all-in-one embedded database, open source. Before I go into that, I just wanted to give a little bit of my background. I'm the founder, NeuML, which is the creator of txtai, and NeuML was founded in 2020. Before that, I spent 12 years building a company called DataWorks, which was a big data software services company, and that led to a successful acquisition in 2019. And after I had took some time off, thought about what I wanted to do next. I wanted to get into machine learning and this space, and started NeuML in early 2020. And the first, initiative I had with NeuML is I wanted to get into sports analytics. I'm super into sports, and I wanted to build some algorithms around that. And I built this application called NewSpo, which monitored the raw Twitter feeds and created these events from things like Manchester United versus Liverpool, or Philadelphia Eagles versus New York Giants, that type of thing. And it was worked pretty well, and had released it in February and late February, and then COVID hit and sports went away. So I don't know if it was all that good of an idea to begin with, but it certainly wasn't a good idea when sports didn't exist. So I had a lot of algorithms I had built, and I tagged on to this Kaggle challenge for COVID research in March and started applying them towards that, and spent a few months doing volunteer research in COVID, and won a couple awards, got some good visibility from that work, got published in Wall Street Journal, and just from there, looked at what I had built through NewSpo and other things, and came to roll that up into what is now txtai in August 2020. And that is kind of the background of where txtai got started. So in terms of txtai, it's an all-in-one embeddings database, semantic search, LLM orchestration, and language model workflows. With an embeddings database, I'm sure many of you are familiar with vector databases. Embeddings database is almost the same thing, but it's more than that. You can take vector indexes, which are the dense indexes we're all familiar with, sparse indexes such as keyword indexes. It also has components for graph topic modeling. It has a component for metadata filtering using relational databases. So with these combination of components, you can run semantic search, you can run keyword search, hybrid, or a combination of both. You can run SQL with vector search. I think that's somewhat unique in this space. It has components for object storage, for topic modeling and relationships, multimodal indexing, indexing images and text, graph analysis. It has it's called all-in-one for a reason. So you can pretty much spin up a Python process and build an index without any external services. You can pip install txtai and download one single model to vectorize your data set and unplug your internet and be able to run. I think that's also a little unique, especially with a lot of projects in 2023 going more towards an API approach. Uses sentence transformers for embedding text, documents, audio. So when those first two bullets, you now have a database, and from there, there's a couple pieces of components that add on top of that, which to me made a lot of sense to add to this database. Would be pipelines and workflows. Pipelines are transformer models. Think extraction QA or transcription, translation. And now with 2023, everyone's in LLM, so that's another big component as well. Workflows can combine multiple pipelines into a single aggregated business logic. You can expose them as microservices. You can expose them as APIs. You can run as a single process in Python, and that scales pretty well for a couple million records, or you can scale it up with container orchestration and have multiple nodes. You can build in Python. You can also build workflows in YAML, and there's API bindings for JavaScript, Java, Rust, and Go. So I'll step into each component and explain some of these through some examples, but also the high-level view of each piece. So a lot of you guys have heard semantic search. I think a lot of people on this are familiar with it, but for those who aren't, traditionally with search, through most of the time, it was keyword search, or it's going to be token based. So you have a repository of text, and it goes through and it tokenizes it, splits it into words or stems, and there's all sorts of sophistication that comes through that. And it will go and do the same for the query, and then try to find results that match. So if you look for something like feel good story, it's, good's going to be an important word, and it's going to look for a lot of matches that have the word good. It's going to look for matches that have the word story. It's going to have matches for the word feel, and it's going to find those combinations. Semantic search, a little different in that it's going to not necessarily look for keyword matches, but it's going to look for semantic or concept-based matches, topic matches. So if you look in this purple box, this is a pretty carefully constructed example of what that means. Each on the left-hand side, you have the query, and on the right-hand side, you have the match. And for each query, the match doesn't have the actual word in it, but it does match as a human would read it. Feel good story, someone winning the lottery. That seems like a good story. Climate change, an ice shelf collapsing. That's related to climate change, but it's not necessarily mentioned about climate change. And looking down, dishonest junk, something about making a bunch of money, $100,000 a day. You have to actually read the text, but if human reads that, it's like, all right, that makes sense. So how does that happen? Semantic search, I think for most who are familiar with keyword search, what is the difference? Semantic search starts with vectorization of text. You need to be able to take text or whatever you're working with. In this form, we're going to talk text. You need to vectorize it or use a machine learning model to convert the input into some sort of fixed dimensional vector. 384 dimensions, 768, 1536. So you take text, you convert it into these arrays of numbers, and you hope that in dimensional space that similar concepts are going to be clustered in similar spaces. Then you take those arrays and you load them into some sort of index. It could be an approximate nearest neighbor, anything that can take and store and do a good job of finding similar batches of numbers fast. In this case, things like HNSW or face, that's what txtai uses. Then at search time, you want to take the input and you also vectorize it, and then you use a similarity metric to find similar matches. So that could be dot product or cosine similarity or other. In txtai, everything is working on normalized vectors, so it works with dot product to find similar matches. And some of those other pieces I'll step more into later in terms of rule-based filtering. So now we've got a vector database or embeddings database. We have data, and we could just run searches, and that's great. But now, and looking into 2023, with LLMs really taking over and being able to find things and do some really amazing tasks. One of the things that was quickly discovered with LLMs or large language models is that they don't do a great job of answering questions that have a quote unquote right answer. It's going to generate plausible continuations of text. So one of the most popular techniques that have emerged is retrieval augmented generation, or the concept of running a query for whatever you're looking for and finding the most similar results, and then taking that and plugging it into a prompt, and then asking the question in a prompt-based fashion, and having the LLM actually create the answer, but constricting it to how it creates the answer. And a lot of great applications have been built off of that, and txtai has a component for doing that whole piece. It also can really hook into the data. You've already indexed the data in txtai, so you can take advantage of the vector piece and then join it with open source LLMs. For the most part, it could also connect to APIs if you want to go down that approach. Being that txtai is an open source library, I'm heavily vested in looking towards open solutions. So out of the box, it uses a lot of Hugging Face transformers and other LLM approaches like that, but it could easily hook into an API if you want to go that approach. Semantic workflows, given that txtai was created well before 2023 and 2020, back when LLMs weren't really a thing in many ways. There's a lot of other components and different ways of joining models. And there's this concept of semantic workflows. So as you see through each of these tasks, you could have a model that's really good at summarizing and combine that with a model that's really good at translating. And that could be your workflow. And so think about if you had 10,000 documents or 1,000,000 documents or 10 million documents stored in a vector index, and you wanted to find the best matching document, but not only did you want to find the best matching document, you wanted to then summarize it into an abstract, and then you wanted to return the result in French instead of English. You could do that with a workflow. You could also do it with an LLM, but possibly for a workflow, it could be faster and cheaper for some of these smaller models. And another initiative that's not here that I've been working a lot on my own research is concept of micromodels, because I do believe that over time, it might not be through the current iteration of transformers in terms of transformer models, but I do believe that we're going to have better control over modeling and better control over the parameters. I don't think we're going to just have trillion or 10 trillion token models, but we're going to have aggregated versions of those. And some say GPT-4 is already that way. But I think that that concept of being able to say you could have 100 million parameter model that's really, really good at medical documents, another 100 million parameter model that's good at finance, and you could have a model that notionally aggregates those up. I think that and semantic workflows are also looking at things in that nature. So I'm going to step through an example using the introduction to txtai notebook that we have. So txtai has about 50 examples, all online. Everything's Apache 2.0 licensed, and there's a ton of examples, which I'll step through a little bit later. But this is the overall view of txtai, kind of in a nutshell. So first thing you do here is you can install txtai. I'm installing it from source because I often update, and I want to be able to update this notebook before I push a release out. But you can easily just pip install txtai, and it'll work just as well. And stepping through the examples to show how it can do semantic search. That same notional example of the 6 different elements here, I have a data array defining them. It doesn't have to be a list. It could be a data set, which is a Hugging Face data set, or any other iterable or generator. It can work on very large feeds of data. It doesn't have to be all loaded in memory. First step, you create an embeddings instance. You pass it a model, which is the transformers model here. And it's as simple as just call index, and you have an embeddings database. And as with the example, this is just going through code and running a series of queries and getting the best result. And as shown before, this is just the feel-good story, lottery example, down to wildlife, someone being chased by a bear. A lot of the examples you see in the txtai notebooks are working off that. And once again, none of the tokens in the query and the match overlap, but the concepts do. Updates and deletes. Wouldn't be a database if you can't change your data. So this example down here, it goes through and it deletes the top, one of the top records, and it just replaces it with a baby panda born, and it runs the feel-good story again. And you can see it initially without that. It's about lottery. After the update, the model decides that a baby panda being born is a nicer story, and it returns that, and then deletes that, and it goes back to the original. Persistence. Embeddings can be persisted to disk. It can be persisted to object storage like S3. There's even a component to persist it to as a Hugging Face model. So if you wanted to take an embeddings and share it on the Hugging Face hub, that's possible. There's a couple examples on the Hugging Face hub. There's one with this notional 6 element example, and there's one with the full Wikipedia feed where you can just load an embeddings right from the Hugging Face hub and run Wikipedia queries. There was actually a research paper that used that model recently. So as you see, just saving and loading doesn't change anything. You can run a query and it gives you the same result back. With the latest release of txtai 6.0, it added hybrid search, which is combining sparse and dense vectors into one. And all you got to do to enable that is you set a flag hybrid equal to true, still having that same path parameter index. And you'll see, in this case, nothing's changed. Nothing was, the whole 6.0 release was sparse / hybrid search. So it was a lot of work to add in keyword indexing. It doesn't use any external libraries for that. It actually was created from scratch for a number of reasons. One, that the libraries that do that in Python I explored weren't performant. They couldn't really, they didn't do a good job both from runtime performance or accuracy. So the version that is built into txtai is pretty close to performance of a Lucene index and pretty close to runtime performance of that. And I have a whole article on how that was done through Python, which was relatively large engineering effort because it's not exactly easy to do things in some cases with Python in a performant way. And just for good measure, you can create an embeddings just with the sparse or keyword component. We'll index it and run some queries, and you'll see no results or feel good story. As I've been saying, there's nothing in here that is going to match from a token standpoint. And if I just search for the just for lottery, it's going to find that one match here because it has the word lottery in it. So next piece, we've talked about sparse, we've talked about dense, and now we're going to talk about the relational component here, or the content storage. Out of the box, an embeddings instance does not store content. It just stores IDs and scores, as you can see here. That's all it's going to come back, and that could be all you need. If you're already have all your data stored in something like Elasticsearch or in Postgres, and you don't want to re-index all the data, but you'd like to add a vector index to it, that this can be done. But if you also want to store content alongside it, which I think adds a lot more powerful possibilities, you just enable this content flag equal to true. And you could also store objects, which I'll get to a little bit later. And you'll see now that when we run the search, no longer do you have to go back to the original data array to get the index and then resolve it. Here you can just run the query, get the text, and it just shows the results. So all we had to do there was set the content to true to get that. And given that it's a relational database, you'll see here I mentioned SQLite. DuckDB could be built if you want to have a file-based relational database. It also supports Postgres or MySQL. Anything that has a JSON column supported in the database can be used, and that it can also persist. It can persist data there. Postgres is an interesting option that's been added with the 6.1 release. I think that opens up a whole host of new possibilities, such as row level access and things like that. If you are in a space where security is super important, or you don't want users to be able to find every record all the time, and that's one way to do it. And I think this approach was a little different than other vector databases, which is trying to pretty much recreate all of this in their own system. I am willing to reuse other systems components, and I'm not trying to reinvent the wheel and create a brand new database with everything being brand new. In the case of sparse indexing, I had to do that, but I use Face, I use HMSW-lib. I would have no problem with hooking into Postgres if that makes sense, because I think that adds a lot of value that's been around for years and years, and it can work with existing workloads. So I wouldn't consider a txtai brand new in the sense that it has to replace, or you have to reindex all your data, and there's no way to integrate with existing systems. So given that when you have content enabled and you have it's stored, you can store these metadata fields. As you see, I'm storing the text, but I'm also storing the length of the text just to show how this would work. And now you can run these select statements. There's a special clause called a similar clause, which will actually go through the embeddings index and gets a similar match in rows, and plugs that into the query, and then you can get those results back, and you'll see returns that. But you also could filter by these metadata fields that are being inserted. See over here, it's got length, and you could run aggregate queries, anything that's in the database. You can select the count or the minimum length or the maximum length. You could group by a field, and similar to how a relational SQL query would work. This would also work if you would have had a hybrid index or even a keyword index. It similar then becomes a keyword query, and for a hybrid index, similar becomes a hybrid query. You have object storage here. We'll load an image and we'll associate that with a record that we insert, and we'll run a query, which is selecting the object. We're similar to machine learning, which is the text in this case. And then I just display that, and it's giving me an image. So you have that component ability to be able to associate objects with your content as well. So that kind of covers the relational piece. We also have the graph piece, which is a pretty big growing area, I would say, as a lot of people are starting to look past, in some ways, retrieval augmented generation and using knowledge graphs as a way to power prompts. txtai already has some of that built in, and that's being built as we speak. Was really taking this semantic graphs to the next level. But the original use case for graphs, why it was added in the first place with the 5x release, was for topic modeling. And the thinking behind having that in there is you already have the semantic relationships, so you might as well go and use those to build topics. And txtai can do that. You can add these, a lot of configuration that it looks like, but it's pretty boilerplate. And a lot of anytime you would add topic modeling in, these would be fairly the same. You can also add zero-shot categories to your topics. And for this notional example, it's not going to give you a ton here, but you'll see it's going to create these topics. If you had a lot of records, it's going to correlate around the most common words, and it's going to take the topic name and look for a zero-shot classification of that topic. You'll see that there as we go through that. It's using community detection algorithms to be able to do that topic grouping. Subindexes, this is going to be more traditional. As you think of a relational database, you're not really looking at a one-to-one index between content and what you can search on. And so with txtai 6.0, there was a push to get subindexes. So instead of just having a single index only being able to have or single embeddings index to only have a single index, it can now have multiple. So in this example, you're setting the content to true, and you're defining multiple indexes. In this case, one keyword index named keyword, and one index for dense vectors named dense. Then you can control, we're going to run this search against the keyword index, we'll get nothing. We'll run this against the dense, so we'll get the result we expect, which is the lottery. This could also be, you could have different models if you wanted to index even the same field with different transformer models for whatever reason, or if you wanted to have, let's say you had a multilingual index and you had different fields for different languages, and you had models that worked better for a particular language, that also could be a case there as well. So you could have it be a hybrid or other external index if you wanted to work in that capacity as well. So in terms of LLM orchestration, this is an example of, really where a lot of people have been spending a lot of energy. txtai has long had an extractor pipeline. It's called an extractor pipeline because it actually originally worked with more extractor QA models. This predated txtai in a way. This was probably the first thing that txtai had. It was part of that COVID challenge I mentioned earlier that had been enhanced to be able to load LLMs as well. And a lot of the pipeline for retrieving context and all of that was already the same. So in a way, retrieval augmented generation certainly wasn't all that new. From txtai standpoint, the only difference was instead of using an LLM to run the logic, it previously ran a extractor QA model. You see in this case, we're creating a prompt to answer the following question using the context below. It takes in the question, and it'll append the context using the embeddings database results. Here we're just using a relatively small Flan T5 model one thing that's important or interesting, I think, that you'll see is it can also output references. It's not just going to give you an answer and not tell you why or where you've got its answer from. It's going to give you an ID of the most likely record that provides the answer, so that you can trace back to, it's great that I got this answer, but I'd like to know the source of your information. Where we're dealing with fact-based or important things like medical, where people aren't just going to accept the answer from a machine learning model, but they want to know how it got to that point. That's going to be pretty important. So you can see here what countries having issues with climate change. It gives an answer of Canada, but also gives you the ID reference, which in this case it was using auto IDs of UID5. So that's where that came from. And it could, next step will run that and also resolve it. So it can say, hey, this is why it said Canada has problems with climate change because of this record. There's also an LLM pipeline that can just run the model directly. So you could just run it. This is just a straight LLM query. So that's a piece that if you wanted to not do anything, you could just install txtai and just run LLM queries and don't even use anything within the vector database, and that would certainly work fine. Language model workflows, we'll go through showing an example how it can be defined through YAML. You can define an index in here, it's writable. We're defining a function, which it takes the translation pipeline, so it can actually take machine learning pipelines and directly use them as part of the embedding queries. If you think like a stored procedure, it's very similar in that capacity. This workflow is defined, it runs a search, it runs a translation to French, and then it outputs the text. So load that YAML workflow, let's pass in this query, which is the query we've been talking a lot about, feel good story. And it's going to give you the result you would expect, but it's going to give you the result we expect in French because it went through that workflow. You can also run this pipeline directly at the SQL statement. So this defines it as that workflow where it took the search results and passed it to the translation pipeline, but you could also run that right through SQL. So you could say, give me the results and actually run this function that translates it to French. And you could also, it could be a summarizer or any sort, it could be even an LLM query right here. So it's pretty dynamic in how that would work. You can also run LLM templates through this. The sequences is just it's a sequence model, so still LLM like. You could also call this LLM as well. This workflow is just a simple couple template steps. It says translate a statement, which is a parameter, to a language if it's English, and then the next step asks what's the text. So in this case, it's hello, how are you, which is English. It's going to translate it to French, and then it's going to ask the language. The second case is German. It's going to say, I'm not translating it because it's not English. And so you see the results, French and German. So that's really high level overview of txtai as from examples. There's also, everything's on GitHub.
And I've gone ahead and posted the link in the chat for the notebook.
Yeah, and everything's on GitHub and everything. There's all these examples here that you could see. Lots and lots of examples which been created over the last 3 or 4 years, and every once in a while I have to go through and update all of them. And maybe I'm not so happy that I created all those examples, but it gives you a lot of hopefully different ways you can use txtai.
All right, and it does look like we have 2 questions in the Q&A if you want to hop on those.
This embeddings what I mean. So I think what you're asking is, it's a little bit of an overloaded word, especially when I'm saying, embeddings database, but in the context of embeddings within this framework, it's really talking about vectors or fixed dimensional vectors of information, the concept of taking text and converting that to a series of floating point numbers. Okay, one other question. Yes, I mean, it doesn't have to be prompt based. If you just wanted to run a API query and run a search and get results back, that's actually the easier use case.